Good afternoon. Thank you for coming to our senior design presentation. I'm Jeff Saporito. This is Lizette Lachoa, Tessa Schaefer, and Josh Higgins. We designed a wet prairie wetland to be implemented within the Oregon Country Fairgrounds. A wet prairie wetland is characterized by wet and dry periods and plants native to the Pacific Northwest.
So our objective for this project is to design a wet prairie wetland on the Oregon Country Fair's property. We want to use treated secondary effluent from the wastewater treatment facility, and the secondary treatment is the removal of BOD, which is the biochemical oxygen demand, and the TSS, which is total suspended solids. We want to meet future regulations, which includes thermal loading and nitrogen loading. And we want to incorporate a western pond turtle within the wetland. So we want to know, can the borrow pit actually handle the thermal and nitrogen loading? So this is a locations overview of the city of Bonita. We have Highway 126 running through the photo, and then the Long Tom River indicated as the blue line. We have Area 1 as the city of Bonita's wastewater treatment plant. Number 2 is the Poplar Spray Fields owned by the city of Bonita. Number 3 is where we're going to design the wet prairie wetland, and that's called the borrow pit. And number 4 is the Maudlin Marsh, which 4 and 3 are both owned by the city of the Oregon Country Fair. And then we have existing piping indicated as the red line right there from the wastewater treatment plant to the Poplar Spray Fields, and we'll be using this in our designs.
The design overview. First will be site preparation done as a survey of the area, prescribed berm and herbicide application to kill any invasive species, plant species that are inside the borrow pit. Then a marker layer of 1.5 inch river rock will be placed down due to archaeological concerns. Berms will be created with soil from the Maudlin Marsh, drill seeding, and then pipes. One pipe from the headworks within the spray field to deliver water to the wet prairie, and one pipe going from the wet prairie to the Long Tom River. This will also incorporate western pond turtle habitat. Here's what the borrow pit looks right now. It's outlined in red, just kind of give you a general idea of how it looks. This is the 1.5 inch river rock. Gives you a little bit of a scale as a hand to see. It'll be laid on the borrow pit after the burn because it's an archaeological sensitive site, and any soil that's added on needs to be delineated from the soil that's already there. And this is a cross-sectional view showing where in the black there's the original soil, a little layer on top of the river rock, and then the berms and the channel that will be created. So here's what the final design looks like. There's a pipe going from the headworks within the spray field down to the bottom corner of the wet prairie, and then another pipe going from the top corner of the wet prairie all the way to the Long Tom River. These are the channels and the berms that will be implemented within the green square down here. As you can see, it starts with the water flowing in here and then serpentining around the berms and exiting out the top corner.
So as Jeff briefly mentioned, we need to do a site preparation to remove the reed canary grass on site. If we don't remove the reed canary grass, it's going to outcompete the native plant vegetation we plan to seek. So first we plan to do a prescribed burn, and then that will be done in the fall just to prevent fires from spreading during hotter seasons. And second, we want to do a follow-up with spot herbicide application, and we will use herbicide that's non-toxic to the plants and animals and will be soluble in water, and it will be short-lived also. And so after we do the herbicide application, we will do the rock application to delineate the old soil from the new soil to preserve the archaeological artifacts on site. And then after we lay the river rock, we plan to create the berms. And then once the berms are constructed, we want to seed the whole area with vegetation, such as cattails, bulrushes, grasses, and that was suggested by Linda Boyer, the native plant manager at Heritage Seedlings Inc. And then we plan to seed with a drill seed just to create firm seed to bed contact, and then this will prevent predators and weather from displacing the seeds. After we seed and sow, we will do operation and maintenance once the wet prairie is fully functional, and the maintenance will include checking the water levels, checking the berms, and the vegetation. And operation and maintenance will be done 1 to 2 hours per week during operational hours that are June through September, and then during non-operational hours we would like to visit the site 1 to 2 hours per month.
So the berm construction, like I said, the berms are being created to prevent the water going straight from the inflow here to the outflow and basically short-circuiting and not being in the wet prairie for the entire hydraulic retention time so treatment can occur. So it's going to be serpentine flow. The berms are being created with soil from Marlin Marsh, and up here is a diagram of how it looks. It'll be 5-foot flat part and then 10 feet on the bottom with a 2-foot slope on it, creating a little triangle. That's how the channel's going to be created. The channel's only going to be 1 foot in depth, so there's a little bit of leeway up if it rains and there's more water in there than we had planned for. It's still got enough volume there. There's going to be 5 berms that you can see the brown outlines right here.
So western pond turtles are only one of 2 native species of turtles in Oregon. Currently, there are western pond turtles in the poplar spray fields, which is right next to the borrow pit. Western pond turtles need a slow, permanent body of water with shallow areas along with terrestrial areas for hibernation and basking. A wet prairie wetland is suitable for western pond turtles, and for breeding considerations, the Oregon Zoo has a program to ensure that juvenile western pond turtles can be placed in the wild and thrive.
So to answer the question of can the wet prairie wetland actually handle thermal loading, we start with the general equation, which is the delta E equals the net radiation plus or minus the latent heat plus or minus the sensible heat plus or minus the grand convection. And for our design, grand convection is such a small term in comparison to the other ones, we're going to assume it's 0. And when we rearrange this, we can get the temperature out is equal to the temperature in plus the area times the net radiation, the latent heat, and the sensible heat divided by the flow, the density, and the specific heat. And we have 2 cases we have to look at. Daytime with no clouds, we'll have the most shortwave radiation, and that actually increases the temperature of the water, which isn't good for our design. However, our saving grace is at nighttime with clouds, when we have no shortwave radiation, but we do have longwave radiation removing heat. And the temperature outlaw should go down to the ambient temperature at night, which is around 17 degrees. And I got data from Agrimint and also from University of Oregon's Solar Sensor Monitoring Laboratory. And I use modified version of Newton's equations from physical hydrology.
All right, so currently the city of Anita's existing drinking water supply comes from an aquifer 30 to 100 feet underground, and the nitrogen inflow concentration from the wastewater treatment plant is approximately 22 milligrams per liter, which is about 55 pounds of nitrogen per day if you take into account the 300,000 gallons of water coming into the wetland. And that's a high amount of nitrogen. And so this means that no water can percolate into the groundwater. And it was calculated from literature that the effluent of nitrogen coming out of the wetland would be 3.7 milligrams per liter concentration with a hydraulic retention time of 2.5 days. And a hydraulic retention time is the length of time of water it is expected in to remain in the wetland. And this calculation shows that the nitrogen meets the groundwater drinking water concentration of 10 milligrams per liter. But our team feels that the nitrogen removal will be a problem, especially during the summer months, when looking at our plant uptake and denitrification values. So as you can see, there's 3.3 pounds per day of plant uptake removal of nitrogen compared to the 55 pounds per day coming in of nitrogen, which is only about 6% of the removal. And there is a large value for the denitrification, but the rates are dependent on nitrification and the microbial activity, which is dependent on the environmental factors. So nitrogen may be a problem, and we want to be 100% confident with it, so a pilot study needs to be done. All right, so the EPA and the DEQ regulate NPDES, which is the National Pollution Discharge Elimination System, and Veneta's wastewater treatment plant's NPDES limits discharge into the river during the summer months due to a high temperature and the potential increase of bacteria. And so our suggestion to handle this nitrogen problem is to get the DEQ to approve discharge into the Long Tom River. And since the temperature is down to the ambient nighttime temperature of 17 degrees Celsius, which is 63 degrees Fahrenheit, it meets the mortality prevention temperature of 68 degrees Fahrenheit for trout and salmon species.
So another objective we wanted to meet with our design was to include the community, And so we discussed two options. The first was to do educational tours for grades K through 12. And then the second was implementing an informational display board in the event location that the Oregon Country Fair holds. And then the informational display board would just hold information like what a wetland is and the environmental and social benefits we get from wetlands. So now the question is, how much is this going to cost? And so I just want to state right off that we need to talk to relevant bodies and agencies about the safety costs included in our design. So the total initial cost is tentative. But as you can see, the highest cost came from the construction and site prep, which came to around $41,000. And then next came the labor associated with the construction cost. Following the labor was the plant and equipment at around $5,000 each. And we did include the operation and maintenance fee in the total initial cost, which came to around $1,000. So the tentative total initial cost is $66,000, but it will increase with the safety cost.
So what can we conclude from this? Well, we conclude that if we discharge at night, that we can meet the thermal loading discharge problem. And the nitrogen loading can be handled if we discharge in the long-term river. And we can also create suitable habitat for western pond turtles, and the initial cost of a PRAIRIE is going to be tentatively $66,000, but once we include the safety factor, it will increase. And these are the people that we would like to thank for their time and help. Are there any questions?